3D file formats are now probably the most popular import formats for either subcontractors or for production departments from their engineering design departments. The Radan software is equipped to deal with all of this. We have import facilities for all of the industry standards, including Pro-E, Inventor, SolidWorks, Solid Edge, etc. And that includes individual parts or even assemblies. Also within the Radan 3D is a powerful sheet metal software for generating sheet metal parts. Okay, so here is a 3D model made up of various sheet metal parts. Now that could either be, again, generated within the Radan 3D from scratch or imported from one of the formats mentioned. So once a subcontractor receives the part, they obviously need to know whether they can manufacture that part or not. So the first step really is to see whether they have any press brake tooling available. So what I'm going to do now is I'm going to select the Radan CNC module. All I have to do now is to select one of the parts in there. I'll select this part here. Okay, this now drags the model into the Radan CNC module. Okay, as the part's imported, a fair bit of work's gone on in the background. It's already determined a bend sequence for this part, and you also notice that the forms are also included in the import. Now that could be important because we will be checking to see if there are any clashes with forms with the tooling. So the next stage is simply to select a machine, and here you can have various machines. I'm going to select an AccuPress, and a machine common in the USA. Okay, now I've selected the machine. You can see the tool railing across there, the part with its sequences on the right hand side, and on the left hand side we've got a tree showing the bends. What I'll do now is I'll select the tooling button, and that's going to search the tooling database available for this machine, looking for appropriate tools. And you can see there some tools on the rails, and if I hover over it at the bottom right of the screen, you can see the profile of the tool. Now it's very manual as well if you want it to be, as well as fully automatic, so I can just click on the tools, drag them around, move them where I want to. I'd like to select some back gauge positions for this part. Okay, and you can see now that back gauge positions have been put on the part, and I can have a step through there and see how that's being done. Okay, what I really need to do now is run through the simulation of this part, and that's going to check for any clashes with the part and itself, so if the bends are too tight, etc., for the part with the machine, the part with the tooling, or indeed the part with the back gauges. And you can move around, zoom in, have a look at any stage during the simulation. Okay, so we notice now on the left hand side of the screen all of the bends are in black. That means that we haven't had any problems and we can produce that part. So all that's needed now is to press compile, and we will generate an NC program for that part. And you can do the same for another part. So okay, let's just get into the 3D environment here. Let's just edit this one, and we know we're happy with that one, so I can edit the part on there and make that invisible. And there we can start to see more detail, sheet metal objects within that part. Okay, so let's select the top section there, and what we'll do is we'll drag that into the press brake module as well. Again, here we have the part in the 3D environment of the simulation. Here's the blank with the sequence predetermined. I'm going to select my machine again. Now I'm going to select the tools. Again, this will search the database, and the database has favorite tools as well. So you can say, hey, this is my favorite tool. I want to use this all the time with that part. And it will check to see whether it is valid to use that tool. So if it's not, then it will go again searching the database for a valid tool. So I'm going to press the back gauges now, find some back gauge positions. You can see at the bottom of the screen now it's just sequencing and checking the back gauges for each of those bends. Okay, so now that's completed. You can see the back gauges there. And we can do all sorts of different things with the back gauges if we wanted to start getting manual with it. So we can say just use a different face. So you see here now it's using the support. Go back again. We can just click and try different combinations to see what's going on. You see it's picking on the face there, etc. Closer to that bend. Okay, so if we stick with the original configuration, run the simulation now, let's check to see if there's any collisions with this part. Now when the model is imported, the software analyzes the bend radiuses that are required and then searches through the database of the tooling and calculates which will give the closest radius for the part, depending on the tooling selected. You can then pass that information back to the model and get the correct development. So again here you can see that everything's in black now. We're now able to compile that program ready for the press brake. If you did have a failure with a press brake, what you can do is we have a tool, obviously the tool editor, which is the database here that's going to show all of the tooling available to this machine. Okay, now that's crucial because it will look at every single piece of tooling that you have ready. So if we look at this tool here, I can click on it and see it, this one here, and these are the section lengths available and the quantity of those section lengths. But there's also a tick down here to say whether something's available or not. So you could actually store, say in this case a Wheeler catalogue. You could store all of the Wheeler catalogue in your database, and then when you run the tool selection you can tell it, instead of just searching for the ones I have, if that fails, try searching the whole database. So then you can actually try out a Wheeler tool before you've even purchased it, so you know for sure that you're going to be able to produce the programs with the tooling that you're going to purchase. And another interesting point to that is, with showing your tooling, you can give the design office, they can have a look and run simulations on the press brakes, and they can look at the possibilities that can be achieved with the press brake. So there's no more taking the part down to the shop floor, seeing whether it bends or not. That's all stopped. No interference with the machine. You know that this part will run on the machine without any interference on the shop floor, and no production downtime. Okay, and again you can see we're working our way through these parts, so we could just go into here again, switch off this part. We know we're okay with that, and we can just pick another part. So Radan CNC, select a face on the part, again here we have the sequence, and a part there. So we can select a machine, select the tooling, and select our back gauge positions. And again, we can see the part there. We can actually analyse this. We say we're supposed to have a radius of 0.5 tools, and we can show consequence of selected tools. And we're actually going to get a radius of 1.35. So we might want to pass that down to the model and correct that. So we're going to get the correct blank. Okay. So here's our part there. Let's just make sure we can actually produce the part. When selecting the tools, the software will always check to make sure that the tonnage is correct for the tooling, and of course the tonnage is correct for the machine. So that's all considerations that need to be looked at when we're bending a part. And that information is then obviously we need to pass that information back to the Radan 3D and make any changes to that part. So I shall actually now go in here, edit this part, properties, bend radius 1.125, apply, close. I will now have the correct radius applied to that part, ready for production. Okay, again, so what I probably want to do now is create a blank for a part. So if we just pick something at the bottom there, so I don't know. What I'm going to do is I'm going to add a development now. So pick one of these parts, say this part here, and it's looking at the bend table. We can have a develop specific neutral axis, or we can have a bend table. So you can do all this automatically straight into the part editor, and you've got the option here to add corner relief, smooth relief, etc. I'm just going to smooth this one. Right, okay. So here we have this part inside the part editor. I can check to make sure that it's a closed profile, which I know it is from there. I can then just take that into the tooling area. So I'm set up for a trump, so I press apply to that. That will search the tooling database, and we can see actually we've got an area red there. We're going to struggle to add tooling in there because that's really tight. No problem there. So what we'll do is we say no, we won't tool it from there. We'll change the machine tool to a bistronic laser. So now we can add the tooling again, and there you can see the tooling added to the part with no problems. So that's now ready to be nested. And of course you have the option if you want to either tool the part during the nesting or before the nesting. Okay, so once I've actually imported all of those parts, the next thing I'm really going to have to do is to create a nest project. So what I can do is I can open a project of all of those parts. And now I can see those parts at the bottom here. And here I can have a window here to show me any nests that I have. So I'll just delete those nests there. And you can see my list of parts there. If I hover over one of the parts, it tells me how many there are required, so I've got a schedule in there. Now what I'm going to do is create this nest on the bistronic laser. So what I'm going to say is run the nester. It's now going to recall all of those parts, check the geometry, and it's going to start producing nests. So if you look on the right hand side now, we can see the nests starting to fill up. And you can see the status of each of the parts changing as the nest continues. And you can see the ticks now indicate that these parts have now been produced within the nest. Okay, so the nest was created successfully. Do you want to view it now? So I'll say yes to that. Okay, here is my last nest. And if I click on this, this was my first nest. and I can step through all of those and look at the parts. Okay, so if I actually now have a look at the last nest, just have a look in here. If I go to the tooling mode, you can see that it's added what we call a scrap cut along this part. Now it's cut this part off so this can be usable material again. You might say, well, why has it cut it off there when it could have cut it off there? Well, we can make it do that, but what I've said here is I don't want a lot of remnants hanging around on my shop floor of unusable sizes. So what I'm saying to the software is, if you can cut off a remnant that's either 400, 600, 800, 1000, 1200 or 1500, then cut it there, because that will provide me with a usable size. And if I look here, remnants made, the information is stored. So I've got that information there about remnants created during that job. So that nest is now ready for production. So I'll just go back to my nests again. Just generate the blocks. And here you see my NC code ready to run the machine. So very quickly, from receiving a 3D model, you can check whether you can produce the part, so you know whether you've got the right press brake tooling to do that. You can also check the implications of your press brake tooling on the actual sizes of the parts, so you're going to create blanks that are the right size for the job. And now you have your NC code ready to go.